Hi, I'm Tom, coming to you from Cleveland, Ohio. Thank you for selecting my video. In today's video, we will be discussing the topic of bulk fermentation. As a beginning sourdough baker, this is one of the most complex, frustrating, and confusing aspects of baking sourdough bread. It's when you're trying to find out when is bulk fermentation done. This is the great mystery of sourdough baking. I'll be baking a loaf today, and I'll be focusing specifically on some of the tips, tricks, nuances, and key things that I look for during the bulk fermentation process to help you understand how do you determine when is bulk fermentation done. So I call this video the mystery of bulk fermentation. As some of you may know, I have two other videos that also cover aspects of this topic. The first one is my 5-part series, The Sourdough Journey, Beginner Mistakes and Tips, where I go through the entire end-to-end process, and there's a very detailed section in part 2 and part 3 of that video that talks about bulk fermentation. And then I have a second video called Overproofing or Underproofing, A Tale of Four Loaves, where I go through the process of baking 4 different loaves and slightly varying the bulk fermentation time and the final proofing time. You might also find those 2 videos helpful if you're interested in this topic of bulk fermentation. But today, we will really go into detail on this one very narrow aspect of the baking process, bulk fermentation. As you may also know, I follow the tartine bread basic country loaf recipe. If you're not familiar with this recipe, this is really the basis of what I'll be talking about as we go through the process today, and I cover that in detail in my other 2 videos. Different recipes call for different bulk fermentation times, and this is what is so confusing and complicated specifically for beginners, is that when you start comparing recipes, like this recipe, the tartine recipe calls for bulk fermentation of 3 to 4 hours, and it calls for the dough to rise by 20 to 30%. Another recipe that looks like it bakes the exact same loaf might call for a doubling in volume of the dough, so 100% increase, and it might suggest 8, 10, 12-hour bulk fermentation. So as you start to look at these different recipes, it's incredibly confusing, and somebody might ask the question, how does this even work? How could two sourdough bread recipes be so entirely different in terms of the bulk fermentation time and the recommended percentage rise in the dough? How is this even possible? And are these recipes even meaningful if there's that much difference in the same step, bulk fermentation, in 2, 3, 4 different recipes? If you look at them, they all seem to be different. The reason that the bulk fermentation times are different is because that the sourdough baking process is a very complex intersection of the recipe, which is the ingredients, and the process, which is the time and the steps. These 2 things are inextricably linked, and each recipe that you follow in a book is not just the list of ingredients, it's the list of ingredients plus the specific steps that go with those ingredients. And that's why these recipes differ. And where beginners typically get tripped up is where you try to interchange parts of different recipes. So I take the first few steps from one recipe, I use the flour ratios from a different recipe, I use the bulk fermentation from a third recipe because I'm in a hurry, so I pick the short one. I use an overnight retard in the refrigerator because I can't bake until tomorrow. And I start to mix and match all these different pieces of recipes. And then I wonder why my bread failed. And it's because the pieces are not interchangeable. They're all inextricably linked. So what we'll talk about today is when you look at a recipe and you look specifically at the bulk fermentation time, you should be able to understand why is the time what it is. So if it's a short bulk fermentation, there are reasons for that. If there's a long bulk fermentation, there are reasons for that. And the more familiar you become with this process, you'll be able to look at different recipes and say, okay, I understand why this one is short. I understand why this one is long. So when we ask the question, why do bulk fermentation times vary across the different recipes? There are 6 primary factors. There are probably more. I'll only cover 6. The first one is it depends what type of flour you're using. So if you're baking a loaf with 100% bread flour, the bulk fermentation will typically be longer than if you're baking a loaf with 50% rye flour. And why is that the case? Because different flours, rye, whole wheat, semolina, spelt, white bread flour, all have different types of fermentation activity when those interact with the yeast and the microbes in your starter, and some of them ferment faster than others. For example, rye is like supercharging a recipe. When you put rye into one of your recipes, the bulk fermentation will typically happen much quicker, whereas bread flour or even spelt is on the opposite end of the extreme, where that will ferment very slowly relative to something with rye flour or whole wheat flour, for example. So the important factor is not to try to understand how all these different flours, may impact the bulk fermentation time. The important point is, if your recipe calls for a specific type of flour or a specific ratio of flours, that ratio of flour that you're using is what is used to determine the bulk fermentation time for that recipe. So you can't interchange the flour and expect the bulk fermentation time to be the same. For example, in the tartine recipe, this calls for 90% bread flour and 10% whole wheat flour. If I said, I want to mix things up today, I'm just going to put in 80% bread flour and 20% rye flour, and then I tried to follow the rest of the recipe, the bulk fermentation time would likely be too long in that case because the rye flour is going to accelerate the fermentation. That's just a simple example. So the first thing is stick to the flour that's recommended in the recipe, because the ratio of flour is inextricably linked to the bulk fermentation time that's recommended in the recipe. The second thing that impacts the bulk fermentation time is your starter. So, and there are two aspects of this. One is the quantity of the starter. This is my starter that I keep on top of my refrigerator. That smells really good. I just had to take another whiff of that. Okay, so the starter impacts the bulk fermentation in two ways. One is the quantity of starter in the recipe will either speed up or slow down the bulk fermentation. So the tartine recipe, again, as a benchmark, uses 20% starter relative to the flour weight. So it's 1,000 grams of flour. In this recipe, it's 200 grams of starter or leaven, actually. The leaven or starter at 20% ratio will impact the fermentation time. So in this case, the 3 to 4 hour time is specifically related to the 20% ratio of starter or leaven in the recipe. So if I said, I don't have quite enough starter, I don't have 200 grams here, I have 100, so I'm just going to use 100 grams of starter and see what happens. If I did that, I'm changing that ratio to 10%, and then if I continue to follow the recipe and try to do bulk fermentation in 4 hours, it would be underproofed because I don't have enough gas, I don't have enough energy in my starter because I took my starter ratio down by 50%. That impacts the bulk fermentation time. So when you think about a recipe, a large amount of starter or leaven in the recipe speeds up the fermentation process. Small amount of starter or leaven in the recipe stretches out the fermentation process. So we talk about the quantity of starter in the dough impacting bulk fermentation time. The other aspect of your starter that impacts the bulk fermentation time is the strength of your starter. A lot of beginners will make their starter for the first time and you get over anxious. I did the same thing. Your starter's just barely getting up to strength and you try to bake a loaf, your loaf doesn't work, you underproofed it, and the reason is because you have a weak starter. So in addition to the quantity of starter in the recipe, for the bulk fermentation times to work, you also need to have the correct strength of your starter. And I know this is an ambiguous term. What do you mean a strong starter? So I've created a video that you can see here that shows what do people mean when they talk about a strong starter. So you can see in this video, I did a 1-1-1 ratio of feeding. So that was 50 grams of existing starter, 50 grams of water, and 50 grams of flour. I started up, I started this clock, and within 4 hours, the starter doubles in size. It does this every day, it does it consistently. That's what a strong starter looks like. A lot of people talk about strong, mature starter. It's like, I don't know what those words mean. So look at the video. If your starter looks like the video, you have a strong starter. The third thing that impacts bulk fermentation is time. This is one of the most obvious, but again, each recipe has a specific time that's recommended, and these can vary wildly. 3-hour bulk fermentation in some really rapid recipes to 12-hour or even overnight bulk fermentation in certain no-knead recipes. So you have to look at time as the third variable, but the fourth variable, which is temperature, always has to be looked at with time. Time and temperature really can't be separated. So when you're looking at a bulk fermentation element of a recipe, for example, in the tartine recipe, this calls for 4 hours of bulk fermentation with an internal dough temperature of 78 to 82 degrees Fahrenheit. That's 25.5 to 27.8 degrees Celsius. That 4-hour fermentation time, which is relatively short compared to other recipes that you might look at, is based on that relatively high temperature that you need during that time of 78 to 82 degrees. That's higher than room temperature. It's higher than your countertop temperature. So for example, following the tartine recipe, I do what I just told myself to do. I use the appropriate flour that's recommended, 90% white bread flour, 10% wheat flour. I use the appropriate starter, which was 20% of the total flour weight, or 200 grams. And then when it gets to the time and temperature, it says the temperature should be 78 to 82 degrees and the time should be 3 to 4 hours. But I look at my thermostat, it's 72 degrees in my house. That's close enough, so I'm just going to leave my dough on the countertop at 72 degrees, and I'm going to ignore the recommended temperature, but I'm still going to set my timer for 3 to 4 hours. Your dough will be underproofed because it's the combination of time and temperature that really makes the proofing work. And I'm using the term proofing and bulk fermentation here interchangeably. So when you think about time and temperature, always think about those two together. They can never be separated. The fifth item that affects bulk fermentation is how much you're handling the dough during the fermentation process. And this one is incredibly complicated. Some recipes call for what's called the stretch and fold method. That's what we do in the tartine recipe. I'll be demonstrating that today. Other recipes call for coil folding or lamination, which is a different variation on the stretch and fold process. And some recipes call for no handling of the dough during bulk fermentation, and these are considered the no-knead recipes, sourdough recipes. So depending how much you're handling the dough can also impact the bulk fermentation time, because two things are happening. One is, as you're turning and folding the dough during the stretch and fold process, for example, you're actually activating the microbes by moving them around in the dough. So if you think about it, your yeast and your lactic acid bacteria is sitting in your dough when you mix it all together, and it can't move around in the dough. It can't walk, it can't swim, it can't move. So it's just eating the sugars and starches that are adjacent to it. So by turning and folding the dough, you're aerating the dough, you're moving the microbes around in the dough. So in some ways that movement is actually activating the fermentation process. So that actually is helping the fermentation go a little faster when you're doing the turning, folding, etc. But at the same time, you're degassing, you're pressing air out of the dough. So the yeast is trying to build CO2 in the dough, and every time you handle it, you're pushing the dough out. So this now impacts the sixth variable, which is the percent rise in the dough. So how does the rise work? So if you have a bowl of dough, like I have right here, this is just getting ready to start bulk fermentation. I need to add my salt, and then this will be ready to start bulk. Most recipes call for, during bulk fermentation, it's a certain time, it's a recommended temperature, and a percent rise in the volume of the dough. So for example, the tartine recipe calls for a 30% rise in the dough in the 3 to 4 hour period with the stretch and fold process. So as I'm doing the stretch and fold during that bulk fermentation time that's included in that 3 to 4 hours, I'm pressing the dough down. So I'm pressing down on the height of the dough during that process, and it's only during the last 2 to 2.5 hours that I'm letting the dough sit, and that's why in this specific recipe it will only rise roughly 30%, because I was doing all that handling early in the process. In other recipes where there's no handling of the dough, the no-knead recipes, they may call for the dough to double in size because you're not touching it. You're just letting it sit there and you're allowing the yeast to keep working and working and working, and you're not degassing the dough or pushing the carbon dioxide out of the dough through the handling. So you'll tend to see higher percentage increases in size recommended with less handling, and the ones that require more handling through the bulk fermentation process will call for less of a rise in the dough. So those are the 6 elements: flour ratio, the starter, time, temperature, which you can never separate, the handling of the dough, and the percent rise. And I'll show examples of all these as I go. So when we think about the percent rise in the dough, there's often confusion in this for beginners when you read the recipe and it says that the dough should double. There are 2 ways to think about doubling. Doubling can either be by volume or by height. And depending on the shape of your vessel, those 2 things can be completely different. Let me explain. If I have a vessel with a narrow bottom, as the dough rises in this vessel, the vessel is getting wider and wider. So in this example, the dough would double in volume before it doubles in height, because the top of this is smaller than the bottom. And you can see this, you can't see it on the screen, on the video, but this shows the milliliters in this vessel. It's a 2,000 milliliter vessel, and 1,000 milliliters is higher than the halfway point because the next half of the volume, the size of the container expands at the top. So when you're thinking about measuring your increase, your percent rise in your dough, you need to be thinking about volume instead of height. And some people will say, it doesn't need to be that specific. Like, I mean, can't you just eyeball it, or can't you just ballpark it? You probably could. And there are people who love to bake bread without following a recipe, without measuring temperature, without measuring time, and they're very good at it, and that's a skill that some people have. That's not the way that I bake, and if that's the way that you like to bake, is not to follow a recipe, not to measure anything, you're probably going to hate this video. You're really not going to be happy here. So I'm sorry you stuck with it as long as you have, but it's only going to get worse as we go forward, because we're going to be taking temperatures, we're going to be measuring things with a ruler, we're going to be estimating volumes. So I don't think it's going to work out if you're a person that doesn't like to measure things. So back to measuring volume. Here's an example of a type of container a lot of people use. These square food containers, there's a brand called Cambro. A lot of people use Cambro food storage containers. They look like this. This is a different brand. The Cambro containers actually show the liters on the side here, and they're very straight-walled vessels like this. So these are easy to use for bulk fermentation because the height is the same as the volume. When you have a straight-walled, this is almost perfectly rectangular, it just makes it easier to measure the percent change when you have something like this where the top of the container is the same size as the bottom of the container. So if this increases by 50%, 50% in height equals 50% in volume. So let me show an example of why this doesn't work when you use a bowl shaped like this, where the bottom of the bowl is smaller or narrower than the top of the bowl. So what I've done here is I've measured out 2 containers with 1 liter of water. So these have the exact same volume of water, and we're going to pretend this water is our dough, the volume of our dough. And I've marked this bowl with exactly 1 liter is where you see that blue tape on here. So if I pour 1 liter of water into this bowl, it goes up to the blue tape, which is almost exactly half of the height. And then if we want to make sure, we could actually measure that. And I can say the height of the water is 5.5 centimeters, and the height of the bowl is 11 centimeters. So it is exactly halfway up the height. Now I want my dough to double in volume. So if I were measuring it based on height, I would wait for the dough to get to the top of this bowl, because that's twice the height. But I really want twice the volume. So when I double the volume, you can see I'm about an inch below the top of the bowl. So if your recipe called for doubling in volume and you waited for this to get to the top of the bowl, you'd be overproofing it. You'd be at about 125%, I would estimate, maybe 130% increase in volume by trying to measure the height versus the volume. So that's the reason that we try to use volume instead of height. So these square containers usually work better. Or this container, which isn't square, but it actually shows the volume-based measures on it here on milliliters on this side. So if you have the markers on an irregularly shaped vessel, you can use those as well. So I started this process about an hour ago. I mixed up the flour, water, and leaven to do what's called the autolyse or fermentalise process. Let that sit for about an hour. And then I just recently added the salt and I mixed that in. So this is in the tartine recipe where the bulk fermentation clock starts now, is after you add the salt. The tartine recipe is a little bit different than some other recipes. So a question that a lot of people ask is, what's the difference between autolyse and fermentalise? Those two terms I just used. Autolyse is technically when you add water and flour together with no starter, no leaven, just the water and flour, and you let that sit. And what it does is it starts to release the enzymes in the flour. It's like the first step in the process. A lot of people do this autolyse process to kind of soften up the flour and start to mix the flour and water before you add the starter or the leaven. With the tartine recipe, what they actually call autolyse in the recipe is actually fermentalise because it adds in the leaven. So you're doing flour, water, plus your leaven or your starter, and that's technically what's called a fermentalise because you're actually you're starting the fermentation process in a step that's traditionally thought of as pre-fermentation. So if you're doing the autolyse process, which is only water and flour, you can let that sit for a long time, and that generally will not lengthen or shorten your bulk fermentation time because you're really just hydrating the flour. If you're doing a fermentalise where you have water, flour, and your leaven or starter mixed together, you're actually starting the fermentation process. So you need to stick pretty closely to the time that's recommended. Okay, we are officially into bulk fermentation. So what are the things I think about now? The first one is I go through the checklist in my mind is, did I use the correct flour ratio? I did, 90% white flour, 10% whole wheat flour. So I've eliminated that variable from the equation. I did not do flour substitution. The second thing is, did I use the appropriate ratio of starter? I did. 20% is what the recipe called for. I put in exactly 200 grams of my leaven, which I built overnight from my very strong starter. I know I have a strong starter. I built the leaven per the recipe. I added the appropriate quantity, so I've eliminated that variable. Now, what I have in front of me is the recommendation in the recipe of the time, temperature, handling, and percent rise in the dough. So let's talk about those separately. So the recommended time for bulk fermentation is 3 to 4 hours. And this is a relatively short bulk fermentation time in the tartine recipe. And the reason is because the second variable, temperature, is pretty high in this recipe. It calls for proofing temperature, bulk fermentation temperature of 78 to 82 degrees Fahrenheit. And that's a little higher than normal. A lot of recipes will call for room temperature, countertop proofing. But in this case, my countertop temperature, my ambient room temperature, is about 75 degrees Fahrenheit. That's 24.2 Celsius. I have to get the temperature of this dough up to 78, between 78 and 82 degrees. So the way that I do that is through a proofing chamber. Otherwise, the recipe won't work. I can't stick to the recommended time if I'm not sticking to the recommended temperature. So my countertop is too cool. I have to think about an option for a proofing chamber. What I use in my kitchen is the oven with the light bulb turned on. That gets my oven temperature up to about 80 degrees, but you need to get it a little higher than the temperature you're shooting for just because it takes a long time for the dough temperature to change. So I try to get my oven temperature up to about 85 degrees if I want to keep my dough temperature in that roughly 80 degree range. So I turned the light on in my oven. I put one of these thermometers in there, and right now it's only at about 78 degrees, so I need to get it a little warmer. So a trick that I do is I boil a pot of water, or in this case a bowl of water, in my microwave. So this is boiling water, be careful with it. And then I put this in the oven, and just the ambient heat coming off of this bowl of boiling water will raise the oven temperature a couple degrees. So let me put this into my proofing chamber. The temperature in there is 76 degrees right now, which is too low. So I have the light on. I added my bowl of boiling water. That'll bring the temperature up. I should have done this a little bit earlier to get the temperature up before I needed to. And I always check the temperature of my dough at every step of the way. This dough is at 74 degrees Fahrenheit. That's too low. Okay, so I'm starting bulk fermentation right now, and I have two problems. One is my dough is too cold at 74 degrees. It needs to be 78. And my proofing chamber isn't up to temperature yet either, so I'm immediately losing time. So you want to think about this. If the recipe calls for 3 to 4 hours of bulk fermentation, there's no way I can hit 3 hours because I'm behind on my temperature. Maybe I can hit 4 hours, but maybe not. So then I need to look at that range and say, because I'm behind on temperature, I'm going to push the long end of time and see where we are at the 4 hour mark. So now that I understand my time and temperature, the third variable that I'm tracking throughout this bulk fermentation process is the percent rise in the dough. When you have your dough in a flat bowl like this, it is incredibly difficult to estimate the percent rise because the bowl is smaller on the bottom than it is on the top. And small changes in the height of this are just very hard to eyeball because the dough doesn't sit at a flat level like water. It kind of shoulders up or domes up in the middle. So this is not a great type of vessel for measuring your percent rise. So what a lot of people use, as I mentioned, are these rectangular food containers like this, or what I like to use is this glass mixing bowl. And you're probably wondering, why was that sitting in my sink and why did I dump that water out? Because this is another trick you could do. My dough is 74 degrees. I need to get it up to at least 78. So rather than putting it in a cold glass vessel, which is immediately going to pull down the temperature, I ran hot water in my sink as hot as it would go. So this is very warm. This glass is very warm. So I'm actually warming up my dough and transferring it to a container where I can more easily see the height of the dough, because this is a taller container. One of the things we're trying to do in bulk fermentation is build the gluten so we can do a window pane test. Normally you do this at the end of the process. We'll do along the way so we can see the difference. So I haven't done the first stretch and fold yet. I have pretty good stretching capability there, just coming out of the initial mix up with the salt, but I don't really have the translucence of the dough where I can stretch that and see daylight through it without it ripping. So that's what you would expect this early on in the process. So the first thing I'll do is a stretch and fold. This is where we are in the process, first step in bulk fermentation. My other video, the Sourdough Journey, Beginner Mistakes and Tips, goes through the stretch and fold process in tremendous detail. If you're interested in how this works, why we do it, many examples, I would recommend checking out that video. I'm just trying to get this started. So this is stretch and fold number 1, just turning the dough a little bit. Then I pat it down here so I get a good marker of where my starting point is. Again, it's hard to do because it domes up in the middle. And then I like to put a piece of tape on here. Even though this has the markers on here of milliliters, I'll put the tape on so you can see it on the video of our starting point. And it's at about 1,500 milliliters in this vessel. The recipe calls for, after the stretch and fold is done, within that 3 to 4 hour window, we're looking for a 20 to 30% rise in the dough, which is relatively small percent increase in the dough compared to some other recipes that call for doubling or whatever. This just happens to be how the tartine recipe works. Because we're doing it at a higher temperature, it doesn't call for as much of a rise. So if I'm at 1,500 milliliters and I need to increase that by say 30%, 33% would be 2,000 milliliters. So there's a 2,000 milliliter mark on this container here. So I'm going to shoot for that 2,000 milliliter mark, which would be a 33 1/3% increase. So that's going to be our end point, and we'll see how that works out. So now I cover this with my elastic food cover, put this into the proofing chamber, which is my oven, for 30 minutes. So we're 30 minutes into bulk fermentation. We are doing stretch and fold number 2. So where are we in terms of temperature? The oven temperature, which I'm using as my proofing chamber, is 86 degrees Fahrenheit, which is a good temperature. And my dough temperature is still a little bit low. I'm up to 77 degrees Fahrenheit. I need to be between 78 and 82 for proper bulk fermentation. So 30 minutes in, I'm still running behind schedule, which means that we'll probably push the long end of the bulk fermentation recommended range of 3 to 4 hours. We'll probably be closer to 4 based on where we are now. I'll do the second stretch and fold, and then we'll get this back into the oven. That dough looks really good. Here's a window pane test after stretch and fold number 2. I'm getting a little less tearing, a little bit more translucence. There it tore. Yeah, it's improving, but I'm still not getting that really thin, translucent effect that we're looking for, but that's not bad. Okay, we're an hour into bulk fermentation. This is stretch and fold number 3. I'm just going to take my dough temperature. It smells really good. Okay, my internal dough temperature is now 80 degrees. That's right in the sweet spot where we want to be, 80 degrees Fahrenheit. That's within the range, the recommended range of 78 to 82 degrees, so we're right in the middle. So let me do stretch and fold number 3. So we got off to a slow start with the dough, but we're catching up now that we're in the range. So that's stretch and fold number 3. And as I said in the intro, you can't really measure the height of the dough while you're doing the stretch and fold process because you're degassing the dough. You're pressing the air out of it every time you do the stretch and fold. So you really don't get any rise at all during this first phase of the bulk fermentation if you're doing stretch and fold. At least I don't. So here's our window pane test after stretch and fold number 3. The dough is much more supple. Look at the stretch that I'm getting now. In terms of height, I'm getting good stretch. And then in terms of the thinness, I can stretch this much thinner now. So I'm stretching sideways. I'm getting some translucency, really, really good gluten development. That is a fantastic window pane right there. Just ripped at the very end because of the whole wheat in the dough. So I'm going to check this temperature again, because sometimes when you put it in the oven or your proofing chamber, the outside of the dough will heat up faster than the inside. So now that I've kind of turned the outside to the inside, I'm going to double check one more time. And now the inside of the dough is 82 degrees. So this is also a common error that people make, is only checking the temperature before you fold it, as opposed to before and after. So it was 80 degrees when I first tested it. I folded everything over. The outside, which is warm, got folded into the inside. So now we're actually over the target temperature for bulk fermentation at 83 degrees. So I do not want to put this back into my proofing chamber. I want to leave this on the countertop now and try to keep that range between 78 and 82. This is where there's a temptation to say, we got off to a slow start. We were running at 76 degrees, 77 degrees. So maybe I should compensate on the high end and let it go up to 83, 84. You don't want to do that, because once you start going over that range of 82 degrees, it changes the behavior, the ratio of the different microbes in here, where the yeast is really operating optimally in that 78 to 82 degree range. And when you start to go above that range, some of the other bacteria will start to run away from the process and start breaking down the gluten in the dough, which will cause overproofing. So I usually do a hard stop when I go above 82, and I'm going to leave this on a countertop now. Okay, we are 90 minutes into bulk fermentation. I'm doing stretch and fold number 4. This will be our last one. This dough feels really nice. It's light and airy. I'm getting a good stretch on it without feeling like it's ripping. You can see how far I can get that up out of the bowl. That means there's good elasticity in the dough. As I mentioned in my other 2 videos, I go through this in great detail, and there are some nice close-up shots of what the dough looks like as I go through this process. This one I'm really just measuring time, temperature, and height. But you can see, I'll just shake the dough a little bit. It's got that real buoyancy to it, which means there's a lot of air in there, which is what you want. So here's the window pane after the 4th stretch and fold. Pretty good translucency right there. Really good. It's exactly what we're looking for. So this dough looks pretty good. And as I mentioned, it's really hard to measure the rise at this level because you keep degassing it every time you handle it. I did put the blue tape on the side at 1500 milliliters when we started. It's slightly above there, but not much. The other thing I look at this point to see is my bulk fermentation working is I look at the sides of the bowl, and you can see there's a lot of bubbles around the side. It means there's good fermentation activity going on. So we're 90 minutes in. I like the way this looks when I shake it. I don't think we need stretch and fold anymore, so I don't want to handle this too much more with more stretch and folds. I like to just wrap the stretch and folds up. I'd rather be conservative and not overhandle the dough than do too much handling. I think this just needs to sit now and rise. So we're 90 minutes in. The recommended time in the Tartine book is total of 3 to 4 hours of bulk fermentation at 78 to 82 degrees Fahrenheit temperature, and they recommend a 20 to 30% rise in the dough after the stretch and fold. So now I'll just do a quick temperature test. 80 degrees. It's right where we want to be. We're right in the sweet spot. 80 degrees. This might run a little bit longer than 3 hours because we got off to a slow start. I'm just going to leave this on the countertop now and see how we do. Now that we've completed the stretch and folds, let's go into a little bit more detail and talk about what happens in the rest of bulk fermentation. So let's talk about what's actually happening in bulk fermentation. This is one of the more complex parts of the sourdough baking process. In bulk fermentation, there are basically 3 things happening. 1 is we're building the gluten structure. 2 is we're rising the dough. And 3, we're developing the flavor of the dough. So how does this work? There are 3 members of the team making all this happen. Number 1, to build the gluten structure, that's your job as the baker. So as you stretch and fold the dough, stretching is building elasticity of the gluten, it's building the gluten structure, and then by folding the dough over, you're basically building a matrix or a grid of gluten. So that's called building the gluten structure. I like to envision that like this grid, this cooling rack. The second thing that's happening is the yeast is filling up the grid with carbon dioxide, and that is rising the dough. That's the job of the yeast. So the yeast basically eats sugar and starch, and it starts filling up each one of these cells that you've created in the grid of gluten in the matrix. The third thing that's happening is the lactic acid bacteria is also eating sugars and starches. That's working in the background, and it is developing the flavor of the dough. So let's talk about an example where all these things go properly, and we'll use the tartine example as our baseline. So in the tartine recipe, as we've talked about, when you build the gluten structure, that's your job. You do 4 stretch and folds. So you complete the stretch and folds, you essentially build the grid. The second thing that happens is the lactic acid bacteria is working in the background, developing the flavor. And the third thing that's happening is the yeast is doing the heavy lifting during bulk fermentation. So the yeast is working at the perfect temperature. So you've created an environment between 78 and 82 degrees Fahrenheit. That's 25.5 to 27.8 degrees Celsius. So the yeast can do its job in that perfect warm environment, and it starts filling up the grid. It works through the 4-hour bulk fermentation period. That's the recommended time in the tartine recipe. And at the end of 4 hours exactly, the yeast fills up the last cell in the grid, and the dough has risen by exactly 30%. That is nirvana. That is the holy grail of bulk fermentation, is when all those elements work perfectly and it ends exactly on time. And this is an example of what nirvana looks like in this type of recipe where you're baking a basic country loaf. You see a very nice dome-shaped loaf, an even distribution of small, medium, and large size holes evenly distributed throughout the crumb. This is a sign of very good bulk fermentation. When any of those things go wrong, you have 2 outcomes. You have underproofing or overproofing. So essentially what happens with underproofing is the yeast can't finish its job for a variety of reasons. So underproofing is caused by 3 things. The first problem with underproofing is that you don't have sufficient gluten structure. So that's where you basically don't do your job building the grid. So if the recipe calls for 4 stretch and folds and you only do 2, you just don't build the grid sufficiently. So you've built one half the size. The yeast shows up ready to do its job. It starts filling up the grid, and it only gets to halfway up, and then it runs out of space to put the CO2, so the dough doesn't rise. So typically, with insufficient gluten structure, you will see a loaf like this. This is one of my early loaves. You'll tend to get a dense, flat loaf. The second reason, which is a little bit more common, that you will have underproofing is due to a weak starter. This is a very common issue with brand new sourdough bakers where you just built your starter, you're anxious to do your first loaf, and you kind of rush that process. You should wait 10 to 14 days at least before your starter has enough strength to really carry the rise in a loaf, but a lot of people get impatient and they rush it. So you've sufficiently built your grid through your 4 stretch and folds, and the bus pulls up with a weak starter. You're expecting 1 million yeast cells, and because it's a fairly immature or new starter, there are only 500,000 yeast cells in there. It just can't do the job. It gets halfway through the buildup of the CO2, halfway through the rise, and it just runs out of energy because you didn't have a large enough population of the yeast to actually rise the dough and fill the entire gluten matrix. Another similar variation on this, and compared to a weak starter, is where you just don't add enough starter per the recipe. This is an easy problem to solve. If the recipe calls for 200 grams, which this one does, add 200. If you say, I didn't make enough starter the night before, I didn't make enough leaven, I only have 100 grams of starter or leaven, and you try to do the recipe with 100 instead of 200, there's not enough population of the yeast to fill the grid. So again, you'll have underproofing due to a weak or insufficient starter based on quantity in that example. So here's an example of what a loaf would look like when you have a weak starter or insufficient quantity of starter. In this example, you can see the caverns inside the crumb, you can see the dense crumb at the bottom, and some separation of the crumb from the crust. These are signs of a weak starter, very common to see in loaves for people first getting into sourdough baking when your starter is just not up to sufficient strength. The third reason that you have underproofing, and this is absolutely the most common, is that you either have too low of a temperature during bulk fermentation, too short of a time during bulk fermentation, or a combination of both. So we're going to talk about all these together. So with the problem of low temperature, you've sufficiently built your grid of gluten, the yeast shows up in the appropriate quantity to do the job, but the temperature is too low, and the yeast really needs to be in that 78 to 82 degree Fahrenheit range in order to finish bulk fermentation in 4 hours per this recipe. So if your kitchen is cool and you just decide to leave it on your countertop during bulk fermentation and your temperature is 69 degrees Fahrenheit, for example, the yeast just works more slowly and it can't fill the grid in the time that you're allowing, the 4 hour time. So you'll underproof based on low temperature. Similarly, you can underproof based on too short of a time. So this recipe calls for a 4 hour bulk fermentation time. The yeast shows up ready to go. The temperature is perfect. You have 80 degree temperature. You've created a proofing chamber. You've put it in your oven with the light turned on. So your yeast is flying through the process at a perfect pace. It's ready to go, but you mistimed something and you have to cut off bulk fermentation at 3 hours instead of 4 hours. The yeast can't finish its job because you didn't give it enough time. So by having too short of a bulk fermentation time, you'll have underproofing. The good thing about all of these examples is the dough tells you if it's underproofed because it doesn't rise. So in this example, we're looking for a 30% rise in volume. And if any of those three things happened, insufficient gluten structure, weak starter or too small of a starter quantity, too short of a time or too short of a temperature, the dough just won't rise. So you can visibly see that your dough will be underproofed because it won't hit that 30% mark. So here are two examples of what underproofed dough looks like when you have too low of a temperature or too low of a time. These were two recent bakes that I had done. One was where I intentionally cut the time short to see what was the quickest time that I could finish bulk fermentation in. And you can see here, this loaf is seriously underproofed because there are large holes in the crumb. They tend to rise towards the top of the crumb, and you see the dense crumb at the bottom. This one was close, but it's definitely underproofed. Another example is where you weren't even in the ballpark. With a very, very seriously underproofed loaf, you'll see these telltale signs of underproofing, which are the tunnels at the top of the loaf and the dense crumb at the bottom of the loaf. That's serious underproofing, very common for beginners, and those are the telltale signs of that. But just remember that when you're thinking about, am I underproofing, the dead giveaway is, did the dough rise? If the dough didn't rise, there's a pretty good chance that you're underproofing. So what happens with overproofing? With overproofing, there are three common things that happen. One is you add too much starter. Again, this is easy. The recipe calls for 200 grams. You should add 200 grams. Some people try to speed things up and they say, I don't have enough time, so I'm going to try to do this quicker. You add 300 grams. It definitely will speed up your bulk fermentation process, and sometimes it will run away from you. And it's very difficult to predict what the impact of adding more starter will be to a recipe that calls, for example, in this case, 3 to 4 hour bulk fermentation time, if you add 300 grams of starter instead of 2, it may be done in 2 hours. It may be done in 2.5 hours. It's very, very difficult to predict. So basically follow the recipe and don't try to overshoot the amount of starter because the bulk fermentation time can run away from you. The second thing that happens is the temperature is too warm. So in this example, we've created a proofing chamber, for example. A lot of people use their oven with the light on, and you don't happen to check the temperature. You just say, a lot of people do this, so I'm going to do it. So I take my dough after the stretch and fold, I put it in the oven with the light on, and the temperature in there in my oven will actually get up to 95 degrees just with the oven light on, no heat turned on in the oven. So the yeast is sitting here waiting to start its job at 78 to 82 degrees. It starts moving, filling up the grid, and all of a sudden the temperature goes up to 95 degrees and the yeast goes crazy. So you're looking at your timer, waiting for 4 hours for bulk fermentation to be done, and the yeast is already done at, say, 2.5 hours or 3 hours. It already filled the grid because it was working so fast at that high temperature. So what happens when the yeast kind of gets to the top, it's filled up the grid, it just keeps pumping air into the grid, and it will start bursting the gluten strands. So it's like balloons. It just keeps blowing up the balloons, and the balloons start bursting all over, and that starts to deflate the dough. The second thing that happens with high temperature is you also start to activate the lactic acid bacteria, which we didn't really talk about in underproofing because it's working in the background, it's staying out of the way of the yeast. When you start to get the temperature up above, say 90 degrees, the lactic acid bacteria loves the high temperatures, so the lactic acid bacteria will show up. It will start consuming the starches and sugars that were meant for the yeast. They start competing for the same food sources. The yeast starts slowing down or not optimizing its process. And after all the starches and sugars in the vicinity are gone, the lactic acid bacteria will eat the grid. It will actually eat the gluten and start to break down the gluten. So what happens with these high temperature overproofs is you take your dough out of the bowl, you pour it onto the countertop to do your dividing and pre-shaping, and it looks like a giant pile of ricotta cheese. It's a slushy looking mess of dough. It flattens out, it's liquefied, you can see the gluten strands in it. That's the dead giveaway of overproofing based on temperature. Similarly, the third aspect of overproofing is too much time. And again, almost the exact same thing happens. The temperature might be perfect, but instead of stopping bulk fermentation at 4 hours when the yeast fills up the grid, you let it go for 5 hours, you let it go for 6 hours. The dough keeps inflating. The yeast starts bursting the bubbles, the lactic acid bacteria starts to eat the grid, and you end up with the same issue. Your gluten structure is now broken down because the lactic acid bacteria and the yeast went past that optimal point, and they start to break down the structure of the dough. Here's what an example of an overproofed loaf looks like. You lose the structure of the loaf. The loaf starts to flatten out. The gluten starts to pull away from the crust. And here's an extreme example called the flying crust, where the gluten is so weak that the crust detaches from the crumb, and you get this giant cavern inside the crumb because the gluten has no strength. The gluten has been broken down by the lactic acid bacteria consuming it and by the yeast overstretching it because the yeast had too much time on its hands, so it just keeps filling the dough, which ultimately bursts the bubble membranes. And the last thing that can happen in bulk fermentation that's not underproofing or overproofing, it could happen in either of those scenarios, is overhandling. Overhandling of the dough is basically where you inject yourself into the process and you do more gluten development, what you think is gluten development, than what was called for in the recipe. So in this example, the tartine recipe calls for 4 stretch and folds, and you might say, I really like the feel of the dough. I like doing the stretch and fold. I'm just going to do 8 of them, or I'm going to do 10 stretch and folds. When you start to do that, you're overworking the dough. So when the yeast shows up and gets ready to fill the grid, you've done it so much that you put another grid on top of it. And now there's double or triple the number of cells in the matrix. So instead of a light, airy crumb with these big balloons that the yeast can fill up, you've created these tiny cells of gluten. So now the yeast is just filling up all these tiny cells because there are 2 times or 3 times more of them. The other thing that happens with overhandling is that some people go beyond the stretch and fold process because they're familiar with baking bread using traditional commercial yeast, and they'll start kneading the dough, or they'll put the dough in their power mixer, countertop mixer. And what happens there, in addition to creating the dense crumb, because you're just overworking the dough with more energy, with more of that strength, you actually start to rip the gluten strands. So now you've just destroyed the grid, the perfectly set up grid that you created in stretch and fold. If you start kneading the dough, you just start ripping this to shreds. So the yeast shows up ready to do its job, and half of the balloons that it's trying to blow up have already burst. You already ripped the balloons. So you get a dense crumb. You don't get the rise in the dough when you overhandle the dough. Here's an example of what overhandled dough looks like. You can see very, very dense crumb, and that's usually caused by human intervention into the process where you just keep working the dough more than you need to. So how do you avoid issues with bulk fermentation? Number 1, follow the recipe. Add the appropriate amount of strong starter that's called for in the recipe. Number 2, monitor the time and temperature of your dough during bulk fermentation. So many people try to guess at this. You really don't need to do that. Measure the temperature, monitor the time, let the science take a lot of the variability out of the equation for you, so that then all you're looking at is the percent rise at the end, and you're not guessing about what was the temperature of my dough. Very, very easy thing to fix, and a common problem that a lot of beginners make is not measuring the temperature and the time during bulk fermentation. And lastly, don't overhandle the dough. There's always a temptation to want to be doing more handling than is required. I would say to challenge yourself the next time you bake a loaf to say, if I strictly follow the recipe, what's the minimum amount of time that I need to be touching the dough? And try that one time and see if your result is different, especially if you're having issues with overhandling. So that was a deep dive into the topic of bulk fermentation, overproofing and underproofing. If you're interested in this, I have another video in the series that I made called Overproofing or Underproofing, A Tale of Four Loaves, where I actually go through and bake 4 different loaves and modify the bulk fermentation time across those loaves and then demonstrate the impact on the loaves. You might find that interesting as well. So we are 3 hours into bulk fermentation. Let's see where we are. So the first thing I do is take the dough temperature. Now this has been sitting on the countertop because we got it up to 80 degrees in the oven earlier, so I took it out. And now on the countertop, it's still sitting at 80 degrees. So you can see the dough takes a really long time for the internal temperature to move very much. Once we got it up to 80 degrees, it stays there. And then look when I try to pull the thermometer out. That's all the gluten forming. I mean, that's a better indicator than the window pane test. So the other thing I like to do at this point, so we know the temperature is in the range, 80 degrees. We know the time is within the range. The recommended bulk fermentation time in the tartine recipe is 3 to 4 hours. We just hit the 3-hour mark, and it makes sense that we wouldn't be done yet because we started out slow. We did not get up to the 78 degree lower end of the range until we were a little over an hour into bulk fermentation. So it would be unlikely that we'd be done here at 3 hours. We're probably going to be pushing 4 hours. The next thing I look at is the height. How much rise have I gotten in the dough? And you can see the blue tape was where we started, and I'm trying to get slightly below the top of this rim. You can't see it on there where the 2000 milliliter mark is. That would be about 33%. I'd say we're 10% of the way. We've seen about 10% growth since we finished the stretch and fold, which is not uncommon. If you're familiar with this recipe, we have a little bit more to go. We want to get to at least 30%. And then the last thing I do is something I call the wobble test. And you're like, what's the wobble test? The wobble test, I don't know any other way to describe it. You just kind of shake the bowl and see how the dough moves. And you can see this is really fluid. It looks fluid, but it's actually just air inside the dough. It almost looks like if this were water, it would splash over the edges. I mean, it's that liquidy, or it appears that way, but it's really all carbon dioxide inside the dough. So I do that little wobble test, and what that tells me is how much air is in the dough. And you'll start to get a feel for that. There's no way really to describe it without seeing it. That's why I'm making this video. Because if you just shake your dough like that, this is one of these pure feel parts of baking, which I hate to rely on because they're so imprecise. But this is one that I don't have any other way to describe it other than showing it. So the wobble test looks pretty good. So it's been exactly 4 hours since we started bulk fermentation. This is the outside range that's called for in this recipe with the range of 3 to 4 hours. So let's size up where we are. So the first thing I'll do is take the temperature. And our internal dough temperature is still sitting at 80 degrees. It's exactly where we want it to be. Halfway between the min and the max, from 78 to 82 degrees. And it stayed at 80 degrees even on the countertop. That's important to remember, so you don't need to keep this in a proofing chamber. Once you get that dough temperature at the spot that you want it at, it'll stay there for a while just because of the density and the amount of water that's in the dough. It'll keep its temperature pretty well. The next thing we look for is the percent rise. The recipe called for 20 to 30% rise after the stretch and fold process. So I look at my marker and we're just at the 2,000 milliliters. We started at 1,500. Here you can see the marker there. So that rose exactly 33 1/3%, 1/3. It's domed up a little bit on the top, but I'm going to call that, roughly a 30% rise, which is what the recipe calls for. So then we ask the question that every sourdough baker struggles with, particularly if you're a beginner: is bulk fermentation done? There's always a temptation to let it go longer. It would be nice to say, I'll just let it go till it reaches the top of this bowl. That would be nice. But in some ways, you just have to go back to the criteria that we talked about at the beginning, the 6 things that can affect bulk fermentation. Number 1, we use the proper flour ratios of bread flour and whole wheat flour, exactly what the recipe called for. Number 2, we used the right starter ratio, 20% of the flour ratio, and it was a strong, mature starter. Third and fourth, time and temperature. We measured the bulk fermentation time at 4 hours, and the target temperature stayed right in that range of 80 degrees, even though we got off to a slow start. That's the only reason that you might want to let this go longer. But then you compare that to the percent rise that it calls for. This recipe calls for a fairly low rise, 30%. We're right at, actually slightly above the 30% rise. So this is where you just need to call it and say, I'm done. It's challenging, because it's much easier to underproof your dough than it is to overproof it. So generally speaking, I encourage people to kind of push the envelope on the proofing until you get a good sense of what your dough should look like and feel like. But when I do this wobble test, this is a very loose dough. You don't want to let that go too much longer, because then you start to get into the dimension of overproofing. The other thing that you want to consider when you're calling the end of your bulk fermentation time is what happens next. So we're going to shape the loaves, do a rough pre-shaping, do a final shaping, and then we'll let the loaves do a final proof. There are two types of final proofing. You can do a countertop final proof for 3 hours per the tartine recipe, or you can do an overnight retard final proof in the refrigerator for 8 to 12 hours. I like to do the overnight retard in the refrigerator, which tends to build more of the sour flavor. If you want a lighter tasting loaf, or if you're in a hurry to bake, you can do the countertop proof. But that's something else to consider, because if you do the countertop proof at room temperature, the dough will actually keep rising. So even if you were a little bit under your target that you needed to be at, and you get 3 more hours of countertop proofing, you'll get a little bit more rise. Similarly, if this started to overproof, if we were right at the top of this container by now, and I had to let it sit for 3 more hours at room temperature, this would be very likely overproofing, because I had gone past the target on bulk fermentation. And then because it's sitting at room temperature, it's going to want to continue, the yeast will want to continue to inflate the dough. So because we're doing the overnight retard, I went slightly past the target. The range was 20 to 30% rise. We're at 33 1/3 basically, because I know this is going in the refrigerator, so there's very little chance of this overproofing. You always want to take that into consideration when you call the end of your bulk fermentation. So I hope that was helpful. I'll go through the last few steps of the process, and then we'll cut this open when we're done so we can see what this dough looked like in the final product. Okay, now we're doing rough shaping of the loaves. So this is where you get another look at the dough as you're pouring it out of this bowl. You can kind of see what it looks like. So as I pour, you can see it's almost liquefied. I mean, if this were totally liquefied, it would be overproofed. I also look for gluten strands coming out of the bottom of the bowl, which you'll see here when it turns over. You can see there were gluten strands visible as this was coming out of the container. As right there, you can see all that striation of the dough. That's the gluten. That looks pretty good. This has a lot of height to it, so as I poured it out, you can see how high this is up off of the countertop. That's a good sign that we had good fermentation. So this looks pretty good. It looks a little wet, a little wetter than usual. Sometimes your flour will behave differently. Sometimes it'll absorb more or less water, just based on the age of the flour or the batch of the flour. So this looks a little wet. It's going to be a little sticky to work with, but in terms of the size of what I'm seeing here, this looks pretty good. So we then pat it, and you can see here as I pat the dough, it's got a lot of action to the dough. See the whole ball kind of moving, it's full of air. That's a good sign as well. And you can hear that sound when you tap it. I don't want to tap too much of the air out of it. Then we divide this into 4 loaves. I'm doing 4 half-size loaves. I don't do the 2 full-size loaves that tartine calls for. I prefer 2 half-size. The half-size loaves are roughly 250 grams of flour weight each. I just tend to prefer to work with that size for my needs. So we have our 4 segments. Now we do rough shaping of these 4 loaves. Flour it up. Flip it over. Now, as I'm feeling the dough here, it feels incredibly light, which is a good sign. Sometimes it'll feel heavy. Sometimes it'll feel exceptionally sticky. This feels kind of light and airy. It's almost bouncing off of the countertop. Then as I fold this over, I'm getting a little bit of resistance in the dough, which is good. That means there's good gluten development. If I wasn't getting any resistance, that would imply that this might be overproofed, but it's not. And then we shape this with the bench scraper to basically get surface tension. I'm just rolling this against the counter and against the bench scraper. to stretch that skin of the dough. It's good. You don't want to overdo it. Next. Two. Looks pretty good. This is really airy, really nice feel to it. Feels like a very puffy marshmallow. You can see how these are standing up as well. That's a good sign that there's a lot of air in the dough. You get this really proud looking ball of dough where it wants to stand up off of the counter. That's it. So that's our rough shaping, pre-shaping, some people call it. We let these sit for 30 minutes. So these are continuing to rise. They're still keeping their temperature. That 80-degree temperature probably dropped a little bit because of all the handling and folding, but these are still rising. The yeast is still doing its action in here. So you're getting another 30 minutes now technically after the end of bulk fermentation. So you want to think about that in your timing as well. Okay, we're doing final shaping of the loaves. I'm doing 2 half-size boules and 2 half-size batards. You can see the loaves stayed standing up quite a bit. They tend to flatten a little, but they still have this really defined shoulder around the edges, which is what the book calls for. That means you have good gluten development. I see these bubbles emerging on the top, which means it's still fermenting, so we still have a little bit of fermentation activity in here. These look pretty good. Then these go in the refrigerator for about, these are going to go about 15 hours. The recipe calls for 8 to 12 hours, but I'd have to get up at 3 o'clock in the morning to bake. I'm going to let them go until about 6 or 7 o'clock in the morning. Once you have them in the refrigerator, there's very little risk of overproofing them, especially in the shape that they're in right now, because they weren't starting to overproof at this point. And then the longer you leave them in the refrigerator, you get a little bit more complex flavor coming out from the lactic acid bacteria. You get a little bit more sugar coming to the surface, so it gives you a little bit darker crust. So we'll let these go about 15 hours in the refrigerator. So it's the next morning. I let the loaves do an overnight cold retard or final cold proof in the refrigerator, and they went for about 15 and a half hours. The tartine recipe calls for a cold retard of 8 to 12 hours. What I found is you can really push that time significantly longer, and I did it just for convenience because of the time that I put them into the refrigerator. I would have had to get up at 3 o'clock in the morning to bake. So this is what drives beginners crazy sometimes, is when we were doing the bulk fermentation, I'm practically measuring the time with a stopwatch where I don't want to go over by 15 minutes or under by 15 minutes. And then you get to the final proofing and it's like, oh, it calls for 8 hours, just let it go for, almost double the time. So it's confusing, to figure out why the times are important, in certain aspects and unimportant in others. And all I can say is when you do the cold retard, basically that term retard means slow down. So you're essentially bringing the whole loaf, the fermentation, down to almost nothing. The yeast at that temperature almost completely stops working at 37, 38 degrees or whatever my refrigerator is. So you won't get much of a rise at all in the refrigerator because the yeast isn't really giving off much more CO2. But the lactic acid bacteria is still working at that low temperature, and that's continuing to develop flavor in the dough, and that's where you really get the sour flavor. And it's also continuing to eat the starches, and eventually will eat the gluten in the dough, which will cause the dough to collapse. But it might take 3 days, 4 days, 5 days in the refrigerator before the lactic acid bacteria will eat enough of the gluten to actually deflate or collapse your loaf. I've never tested that outer limit of overproofing in the refrigerator. I know some people have, by accident, but I participate in a lot of social media groups with sourdough bakers, and you very, very rarely see somebody who says, I overproofed my bread by doing a cold retard in the refrigerator, unless, like I said, it goes for more than 5 days or something like that. So I just baked up these 4 loaves. Now let's take a look at the loaves and talk about what can I tell about bulk fermentation just by looking at the loaves after they baked. So a few things jump out at me. One is if we had overproofed the dough, typically you would see flatter loaves. What happens with overproofing is the lactic acid bacteria starts to consume all the starches, and when it's done consuming the starches, it starts to eat the gluten, which will then collapse the structure of the loaf. So if I just look at these kind of from the top down, none of them look like they flattened out. What you'll see is with overproofing is they would be flatter from a height perspective, but you can also tell from the corners, because the corners just tend to lose the structure first, and you'll see this flatten out into an oval or a flatter circle, and the batards tend to flatten out on the corners. The second thing I look at is just the overall height. The height can be a little deceiving. I mean, this batard looks fantastic with this height, so you would assume this was perfectly proofed just because the shape of that loaf looks so good. But with underproofing, sometimes you get this big buildup of gas with an underproofed loaf, which will actually cause the loaf to puff up at the very end, and you'll get these empty tunnels under the top of the crust. And I just noticed on this one loaf that there's this little high spot right here, which is a little concerning to me. It could be just due to the way I shaped the loaf. It could also be due to underproofing because you get a surge of gas that will sometimes cause these high spots in the loaf, which I see on the two Retards. I don't see that at all on the boules, so my thought right now is it's probably just due to the way I shaped and scored these. That was just a weak spot in the loaf. Obviously in the middle of the scoring you're going to see some of that, but that's something that you want to look at is the height can be deceiving. Sometimes really good height means you had a perfect bake. Sometimes good height means you had underproofing and a lot of gas buildup under the dough. The other thing I look at is the color of the crust, because when you have appropriate bulk fermentation and final proofing, it brings sugars to the surface of the loaf when you get that balance perfectly right, and that's where you get the really dark loaves. I don't tend to bake my loaves really dark. I prefer them a little lighter, especially the boules. I tend to like these a little softer and with this blonde color. But if you look at the Retards, I could have baked these up really dark and they would have kept going, because you can tell that there are sugars coming up. See the burned edge on the ear is the dead giveaway, that you have sugars in the crust, but also just the color is more of a dark brown color, darkening brown color, as opposed to a real blonde color, which is also a sign of underproofing, which means the dough didn't have enough time to work. The microbes didn't give off enough sugars and the sugars didn't come to the surface. You'll kind of get, uninteresting looking blonde loaves. And then just one last thing about the height is, the obvious thing with height is if you underproof your loaf, you tend to get a relatively flat loaf, sometimes with that bubble in the middle. But also if you overproof your loaf, you can get a flat loaf. So the height is tricky because it's not a great indicator of under or overproofing. So I can't tell a lot at this point. We'll see when these cool. I let them cool for 90 minutes and then we will slice them open and look at the crumb, and that will really tell the story of whether or not our bulk fermentation and proofing were optimized. So the last step in assessing bulk fermentation is to cut these loaves open and see what the crumb looks like. It's really the only way to know if your bulk fermentation worked or not. And that's part of the reason that it takes a long time to develop the skill to say, based on what I saw during my bulk fermentation with the wobble test or the height or the temperature, how did it look when I cut open the bread, because you only get one try, per bake. I do have another video out there called Underproofed or Overproofed, the Tale of Four Loaves, where I actually bake 4 loaves just like this, but I change the proofing time and bulk fermentation time on each one of the loaves so you can actually see the difference across the 4 loaves. On this video, I just wanted to go a little bit more into a deep dive into the actual bulk fermentation step itself, but I recommend watching that other video to see a good comparison of what 1, 2, 3 hours difference looks like when you're comparing loaves side by side. So we did these all as one batch, so they probably came out pretty similar. I did 2 Retards and 2 boules, so sometimes you will get a different looking crumb just based on the different shaping of the loaves. Let's take this one first. This is the largest of the 2 Retards, and we'll cut this one open. That's a fantastic loaf. When you look at the distribution of the crumb, you get that nice mix of medium size and small size holes throughout the crumb. You get the glossiness on that large hole right there. I don't see any tunneling on the top that would indicate that it was underproofed. I don't see dense crumb at the bottom that would indicate it's underproofed. And I don't see any of the collapsing around the edges that would indicate that it's overproofed. When it's overproofed, you really start to lose the shape, but that is a fabulous looking loaf of bread right there. I would say that's as close to, perfect balance of proofing that I've gotten in quite some time. That's a good one. Let's try one of the boules. These are a little bit different shape loaf, so sometimes the crumb will look different. These are really soft. I mean, I can tell just by cutting into these that they're incredibly airy, which is the sign of good bulk fermentation. See, this one, we did not get as nice of a distribution of the holes, and that could be because of the shaping. I tend to shape these boules a little tighter than the Retards, and you can actually see that ring, the kind of the shape of the holes in the loaf is because of the way that I did the shaping. I really roll this on itself and was tucking and tucking the dough underneath itself. If you go back and watch the video of how I shaped these, I handled the boules a little bit more than I handled the Retards, and you can see the difference there. The Retards just rose really freely. The boules were pushing against themselves a little bit more because I made a little tighter ball the way that I did the final shaping. You can absolutely see that if you go back and watch that video. So that one's pretty good. Let's look at this other Retard. Now I have to eat all these, then I'm cutting them. Another phenomenal looking loaf. Exceptional distribution of the holes in the crumb. No signs of under or overproofing. Not a lot more to say about that. That's another nice loaf. And lastly, the second boule. We'll see if this one looks a little bit different. It's a little taller. Maybe I didn't shape this one as tightly as the first one. And we'll see if the shaping actually shows any difference. Just because of the height of this one, I can tell it might be a little different. That one's okay. A little bit more open crumb, kind of one big crater here in the middle. Not crazy about the way the boules came out. I mean, you can't call this overproofed or underproofed. It's just the shaping was a little bit tight. And I also bake these in a different Dutch oven than the Retards. The Retards are in my big cast iron Dutch oven, which gets super hot inside. The boules I bake in a smaller, thinner walled Dutch oven, and it just tends to not quite give you that same oven spring as the large cast iron Dutch oven. So I may go to, back to cooking the boules in my larger Dutch oven. I think that's actually the difference. The dough is exactly the same. So this is a great example of when your loaves come out differently when I use the exact same dough. So the proofing was exactly the same. The final proofing in the refrigerator is exactly the same. The bulk fermentation time was exactly the same. So how do you explain the difference here? Two things. One, I shaped these a little bit tighter. And two, I cooked them in a different Dutch oven. Let me show you the two Dutch ovens for comparison. This is my big Dutch oven. This is a, what is this? 6-quart Dutch oven, very heavy, very thick-walled Dutch oven. This is what I normally do all my baking in. That's really my preferred baking vessel. When I need to bake 2 at a time, I have 2 ovens. I have this smaller Dutch oven. You can see the walls of this are thinner. Doesn't quite heat up as much. The lid is thinner, so I'm not getting as much of that superheating. This is what I bake the boules in. So I think that makes a difference. I heated up the 2 ovens to the exact same temperature. Maybe my thermostats are different in 2 ovens. Sometimes your upper oven will get hotter than your lower oven, and I did cook these in the lower oven, the boules, because all that heat from the lower oven is actually irradiating up into the upper oven, so it actually can run a little bit hotter, especially if you're running at maximum heat like 450 or 500 degrees. So I could reverse the order of these. I could bake the Retards in the big Dutch oven in the bottom oven, and then I could bake the boules in the thin-walled Dutch oven in the top oven, and that might actually heat the top oven a little bit more. I could try that. Or I could just reverse put the boules in the large Dutch oven just to test and see if it's due to the shaping, because then that would isolate that variable. That's the only thing that would be different then, is if I bake them in the same Dutch oven, in my top oven, and if it continues to come out differently than the Retards, it has to be because I shaped these more tightly. So unfortunately, I can't do that test here because the loaves are baked, but maybe next time around, I'll reverse these and I'll do the boules in the large Dutch oven just to compare the two and see what the difference of shaping is. But I know that there's no difference due to bulk fermentation because we use the same dough. So this is a great example of how you can learn as a baker. Try not to change too many variables at one time. And in this case, when you do have a difference in the way that your loaves come out, really try to isolate from that bake what were the reasons that it could have possibly been different. I've narrowed this down to two things: shaping and my baking, either the Dutch oven heat or the Dutch oven thin wall versus thick wall. Okay, so it's 1 week later, and I had to know the answer to why that boule didn't work out in the prior bake, where the crumb was a little bit dense. So I redid the same bake 1 week later, and I changed two variables with the boule. One was I did not shape it as tightly as I did last week. I did a little bit looser shaping, similar to what I had done with the Retards. And the second thing that I did was I baked it at a slightly higher temperature. Rather than baking at 450 degrees, I tried baking it at 475 degrees. I can already see that there's a little bit more height to this, probably from the higher temperature. So we're going to cut this open and see what the crumb looks like to see if we rectified that dense crumb issue. And there it is. Much better crumb than we saw last week. So I did two things differently. I did a little bit less tight shaping in the final shaping, as you saw in the video, and I baked it at a higher temperature and got slightly better oven spring. So that's a good example where the bulk fermentation was exactly the same from 1 week to the next, but the shaping of the loaf actually had a pretty significant impact on the crumb. So you always have to keep that in mind. You can't always just assess bulk fermentation based on looking at the crumb, because it's a combination of the fermentation and the shaping. That's it for this video. I hope you found it useful. If you did, please subscribe to my channel, The Sourdough Journey. I'll continue making experimental videos like this. And if you haven't checked out any of my other videos, please do so. My 5-part series, The Sourdough Journey, Beginner Mistakes and Tips, is a great end-to-end coverage of the entire baking process in detail. And the other, Overproofed and Underproofed, Tale of Four Loaves, very similar to this process, but we vary the proofing and bulk fermentation time so you can actually see the difference in those two variables across the loaves. Thank you again.